Hello, everybody. Let's do some extreme value theorem problems. Okay, so 4.21, that is in reference to chapter 4, number 21 of your textbook. I just grabbed some textbook problems today. We're going to work through them. Hope they help you out in the future. So we are tasked with finding the absolute maximum and minimum values of the function 2/3 x minus 5 on the closed interval -2 to 3. So how do we do that? Well, here's our algorithm, our instruction manual for this kind of problem. We take the derivative of f of x. We find the critical points by setting the derivative of f at x equal to 0. And then we solve for x while keeping our definition of critical points in mind, just looking out for times where it's undefined, like if we divide by 0 or something like that nature. Then once we have our critical points, we take these points along with the endpoints and plug them into f of x, and we see what our min and maxes are. So first, let's take the derivative of f of x. So given that we have this nice little line, this is a very simple derivative. The 5 goes to 0, and then 2/3 x is going to go to 2/3 using the power rule. So we have that the derivative is never 0, which means there's no critical points. And also it's totally defined on that whole interval. It's always just 2/3. So our extrema, given the theorems that we know up to this point now, have to be on the endpoints. So here we are with f of x equals 2/3 x minus 5 with critical points -2 and 3. Let's plug in -2. So f of -2 equals 2/3 times -2 minus 5. That's going to equal 4/3. Just multiply it in. Minus 15/3. Just messing around with 5. Combine those, we get -19/3. And then throw that bad boy in a calculator, and you get -6.3. Now we plug in 3. We get 2/3 times 3 minus 5 is equal to 2 minus 5. Just canceling out the 3's in the fraction. And then we get -3. So we have a max at -3, or we have a max at 3, which is -3, and we have a min at -2, which is -6.3. And we can see that right here with the picture. I generated this with Wolfram Alpha if you want to go do it yourself. So yeah, read them and weep, I guess. Here we go. Let's do another. All right, find the absolute max and min values of f of x equals x squared minus 1 on the interval -1 to 2, the closed interval -1 to 2. What are our steps? We take the derivative of f. We find the critical points by solving for f prime of x equals 0 while keeping in mind our definition of the critical points and looking out for undefined areas. And then we take these points along with the endpoints, plug them into f of x, see what we got, and then I'll have a picture and show you what's going on. So given that f of x is equal to x squared minus 1, we take the derivative, very easy derivative, probably the second derivative you did ever, which is 2x. So set that equal to 0, divide by 2, we get x equals 0, we get our critical point at x equals 0. So taking our endpoints and what we found, we have f of x equals x squared minus 1 with critical points 0, -1, and 2. And we're going to plug them in. So f of 0 is 0 squared minus 1, -1. F of -1 is -1 squared minus 1. That's equal to 0. F of 2, 2 squared minus 1 equals 4 minus 1 equals 3. So what do we get? We get that our max is 3 and our min is -1. This time not on the endpoints though, which is nice. Gives a nicer looking example, which here it is. We got this section of our slightly shifted parabola. So f of x equals x squared minus 1 on the closed interval. If you look over at 2, we get our max at 3. And if you look over at 0, we get our min at -1. All right, let's do another. So let's find the absolute max and min values of f of x equals the square root of 4 minus x squared on the closed interval -2 to 1. What do? We take the derivative of f. We set that derivative equal to 0, solve for x, look out for undefined points, tally up our critical points. Then we take these points along with the endpoints, plug them into f of x, see what we got. So given that f of x equals the square root of 4 minus x squared, I just rewrote the derivative a little bit. I used the definition of what a square root is and raised 4 minus x squared to the 1/2 power. So now I can use the power rule and the chain rule, which we'll get right here. So I brought down the 1/2, and then I copied down what I have, 4 minus x squared, and I raised it to the 1/2 minus 1, which is minus 1/2. And then I multiplied by the derivative of the inside. So that's going to be negative 2x. The 4 goes to 0. The negative x squared goes to 2x. Then I did some simplification. The 1/2 and the 2, they cancel out. Then we keep the negative. We are going to move the x into the numerator. And then I have 4 minus x squared to the negative 1/2, which is going to be 1 over 4 minus x squared to the 1/2, which is 1 over the square root of 4 minus x squared. And I'm going to put that in the denominator. Now, given that f prime of x equals 2x over, or negative 2x over the square root of 4 minus x squared, we find the critical points by setting it equal to 0 and solving for x. But we need to be mindful of areas where the function is undefined as we solve. So right here, we have an immediate sticking point. If we plug in negative 2, which is in our interval of things that we care about, we get an undefined point. So negative 2 is a critical point just right here, right now. Now, let's do some simple simplification. Multiply both sides by square root of 4 minus x squared, assuming that x is not negative 2. We've already taken care of it. And we get negative x equals 0, and then x equals 0. Not too bad. There's another critical point. So what do we got? We have critical points 0, negative 2, and 1. So let's plug those bad boys in. Here we go. So f of 0, 4 minus 0, which is going to be the square root of 4, which is just 2. F of negative 2, which is going to be the square root of 4 minus negative 2 squared, which is going to be the square root of 4 minus 4, which is, 0. F of 1, which is going to be the square root of 4 minus 1 squared, equals square root of 3, which is about 1.7, right below 2. So what do we got? We got our max is 2 and our min is 0. Let's check out that picture. All right, here it is. F of x equals square root of 4 minus x squared on the closed interval. And if you look over at 0, we get our max there at 2. And if you check out negative 2, we have our min, which is 0. Oh, wait, let me make sure I said that right. Yeah, at 0, we have our max is 2, and at negative 2, we have our min, which is 0. All right, lovely. Let's do another one. And this is our last one. These problems, once you kind of figure out the flow of it, they're all the same thing. This one's just a little more interesting, so I wanted to work it out as well. So let's find the absolute max and min values of the function f of x equals x e to the negative x on the interval, closed interval, negative 1 to 1. All right, what are our steps? We take the derivative of f, find the critical points by setting it equal to 0 while keeping our definition of critical points in mind. And then we take these points along with their endpoints and we plug them into f of x to see what our minimum and maximum values are. Okay, given that we have our function x e to the negative x, we do the product rule. Look at x as your f and e to the negative x as your g. Then we'll get x prime e to the negative x. X prime is just 1, so you put down e to the negative x. And then x times e to the negative x prime, which is negative e to the negative x. So we'll get altogether e to the negative x minus x e to the negative x. Factor out that e to the negative x, and you'll get e to the negative x times 1 minus x. So given that we have this derivative, we find critical points by setting it equal to 0 and solving for x. We also need to be mindful of areas where this function is undefined. as we solve. There's not too much to do here. We have, I mean, it's very, very clear that if we plug in 1, we get 0, and then e to the negative x is positive for all of our values ever, so we don't really have to worry about anything else. So here we get critical points, which is 1 from our deductions and -1 from our endpoint. But 1 also, incidentally, is one of our endpoints. So, pick your poison. All right, let's plug in those critical points. What do we get? We get f of -1 is negative e to the -1, which is just negative e. That's going to be negative, or about negative 2.71828. And then f of 1, which is just going to be 1 times e to the -1, which is 1 over e, which is about 0.37. And then we'll check out the picture. Oh, well, let me state what our min and maxes are given our information. So our max is 0.37, and our min, boom, negative 2.71828. Now we look at the picture, and we get exactly what our calculations are, which is pretty cool. So here's what it looks like. And if you go and check out 1, you see that we have a value that's, a little bit below 0.5, which is our 0.37 that we want. And then if you look way back over at -1, you see that we have a value at the endpoint that's about negative 2.7. It's a little bit below negative 2.5. So we did it. Okay, guys. Thanks for watching. I hope you learned a little bit. Have a nice day.